Welcome back. In this session, in the previous session and this continuing session, we are talking about types of data integrity controls. And we talked about the hash algorithms, salt algorithms, and the next data integrity control method is your HMAC. So, what is an HMAC? The next step in preventing a cyber criminal from launching a dictionary or brute force attack on a hash is to add a secret key to the hash. Only the person who knows the hash can validate a password. One way to do this is to include the secret key in the hash using a hash algorithm called keyed or key based hash message authentication code, that HMAC, the hash message authentication code, or keyed hash message authentication code, that KHMAK. So HMAX uses additional secret key as input to the hash function. So the use of HMAC goes a step further than just integrity, assurance by adding authentication. So an HMAC uses a specific algorithm that combines a cryptographic hash, the cryptographic hash function with a secret key. This cryptographic hash function with the secret key. So here you can see in this HMAC hashing algorithm, there will be a plain text. That plain text, given as an input to your hash function. Then it generates a digest, the fixed length authentication hat value. So, but here the HMAC, or the use of this HMAC, that goes step further than just integrity assurance by adding the authentication, but the HMAC uses the specific algorithm that combines this cryptographic hash function with the secret key. This secret key may be the private key or public key. Only the sender and the receiver knows the secret key, and the output of the hash function now depends on the input data and the secret key, this input data and secret key. So only parties who have access to that secret key can compute the digest of an HMAC function. So this characteristic defeats man in the middle attack. That defeats the man in the middle attack and provides authentication of the data origin. So what is the HMAC operation? As we just said, the HMAC operation. So here you just consider an example where a sender wants to ensure what a message remains unchanged in transit and wants to provide a way for the receiver to authenticate the origin of the message. So in this figure, you can see the sender device inputs data that pay to Terry Smith, the $100 and 100 and no some dollars of information, and it provides a secret key. This is the data message and secret key. So these both are the data and secret key will be given as an input to your HMAC algorithm. So the sending device input data along with the secret key into the hashing algorithm and calculates a fixed length HMAC digest or a fingerprint. The receiver gets authenticated fingerprint attached to the message. For this message, this digest is attached. So this is the first step here. So then on receiver side, this is on sender side. So on receiver side, the verifying this HMAC value, the hashing message authentication code, right? So the receiver device removes the fingerprint, whatever fingerprint is attached here. This fingerprint is removed, and same received data with the secret key which is already exchanged prior to this data exchange, okay, between two parties. So the receiver device removes this fingerprint from the message and use the plain text message with its secret key as input to the same hash function. So if the receiving device calculates a fingerprint that is equal to the fingerprint sent, the message is still in its original form. Additionally, the receiver knows the origin of the message because only the sender possesses a copy of shared secret key. So the HMAC function provide and in it proved the authenticity of the message. So it is not only providing the integrity, it also provides the authenticity that the message is originated from the legitimate user only. So now let us see the application of HMAC. So this HMAC can also authenticate a web user. Many web services use basic authentication, which does not encrypt the username and password during the transmission. Using HMAC, the user sends a private key identifier and an HMAC, the digest value. The server looks up the user's private key and create a HMAC digest or fingerprint. The user's HMAC must match the one calculated by the server. The digest must match. So, virtual private networks using IP secure that rely on this HMAC function to authenticate the origin of every packet and provide data integrity checking. So we'll see this as shown in this figure. Uh, the hashing uses the Cisco products use, or any company's product, they use the hashing for entity authentication, data integrity, and data authenticity purpose. So the Cisco ISO routers use a hashing with the secret key in the HMAC like manner to add authentication information to routing protocol updates. So that is in data integrity, data authenticity, and entity authentication can be done. So in the IPsec gateway, the IP security gateways and clients use hashing algorithms such as your message digest 5 and secure hash algorithm family 1 in the HMAC mode, that the hashed message authentication code mode, to provide the packet integrity and authenticity. Another Cisco software images on cisco.com have an MD5 based checksum available so that customers can check the integrity of downloaded images. So the term entity can refer to devices or systems within the organization. So this is one of the application of your HMAC. So HMAC can be applicable, applied to your virtual private networks, and in that, like routing, the ISO routers, they use this hashing with secret keys. IPsec gateways and clients use the hashing algorithms, different hashing algorithms, MD5 and SH1 in HMAC. So next, we'll see what is a digital signature. This is very important. Okay. So we'll discuss this digital signature in the next session.